Hi again, everybody. We're now going to do a bit of revision and we're going to find the equation of a straight line from a graph, as you can see by the title here next to me. We're going to do that in two ways. First way is we are going to use the gradient and y-intercept to find the equation. The second way is we are going to choose any 2 points on the graph and we're going to find the equation. Sounds familiar? We did it back in year 8 and year 9 and year 10. Let's do it again right now. So the first way, we're going to use the y-intercept and the gradient. Now you can see on the graph here that it's pretty obvious what the y-intercept is. So this makes this one the choice. Okay, let's quickly revise what we did from year 8 and what's different this year. First up, y equals mx plus c. Remember, m was the gradient and c was the y-intercept. Now, we don't use y equals mx plus c in year 11 in further maths. We do in methods, but not in further maths. In further maths, we swap it around a bit and we write y equals a plus bx. Now, you see the y-intercept is swapped. That's the a, and the gradient is now the b. So let's get into it in this question. First up, we need to find the y-intercept. So that is a. Let's have a look at our graph over here. There it is, it's 3, so simply a equals 3. Next thing we want to find, of course, is the gradient. So if you remember, the gradient is rise over run. All right, now the quickest way to do that is get 2 points. Now we've got one of them already over here, that's the 3, so we'll use that one, we'll circle that in blue, and we look down the line for another easy to get point. Now sometimes you can use the x-intercept as well, down here. Not this time. It's sort of around about 1.5, but we don't know for sure. But we do know back up here, there's another one. That's going right through 1, 1, isn't it? So let's use that one, not lose it, use it. All right, what we need to do now, go back to our first point, and we're going to find our rise. So we start here, and the rise in this case is going to go down 2, isn't it? So I'll bring that over here, down below me, and that will be -2. It's gone down 2. Now I run back to our graph here, starts here and goes across to our line. So it's gone across +1. So that comes down here and will become 1. So -2 over 1, of course, is -2. Time to substitute them back in our equation. There it is, y equals a plus bx. So we'll put the 3 in place of the a, and the -2 in place of the b, which will swap that around to 3 minus 2x. All right. Straightforward. Remember that? Cool. All right. Next one is using 2 points on the graph. Now, here's a graph. We've got 2 points clearly labeled just to make things a bit more easy for you. That's great English, a bit easier for you. Anyway, now you can see the y-intercept isn't marked. So again, it becomes obvious down here which version of finding the equation we have to use. So it's going to be using the 2 points. Again, let's go back. The y equals a plus bx, but this time we haven't got the y-intercept to find. We've got the gradient we need to get. Now, if you remember, that's rise over run. It's also, do you remember this little doozy? Rise over run equals y2 minus y1 over x2 minus x1. Correct. Now, what were they again? Now, they're the coordinate pairs. This is 0.2 and this is 0.1, x and y. So it's a good idea right now to label 0.2 and 0.1. So we'll label it down here, x1 and y1 and x2 and y2. Please trust me on this. We see so many mistakes of people doing things the wrong way around, doing 8 minus 6, and that's y minus x, and it's a mess. Please label your points, x1, y1, x2, y2. Doesn't matter which one's which. That could be 1 and that can be 2. All it's going to do is swap the numbers around up here. Okay? All right, now we've labeled it 2, so the y2 is 8 and the y1 is 2. So on top, we're going to write down here equals 8 minus 2. And of course, that's going to leave the x2 as 6 and the x1 as 2. So you can see that here, which is, of course, 6 over 4. Simplifies to 3 over 2, which, of course, you can write as 1.5. Okay, there's our gradient. Next thing we need to find is our y-intercept. Okay, great. We could, if the graph is drawn accurately, draw it down here, but it's not going to be any good to us. On this one, it goes all the way off the graph. So what we need to do is we need to substitute the gradient and one of the points into the equation y equals a plus bx. Now, the gradient's easy. That's 1.5 here. Which point are we going to choose? The 6, 8 or the 2, 2? I would go personally the 2, 2 because the numbers are a lot smaller. I would rather use smaller numbers, obviously. Okay, so b equals 1.5 and 2, 2. Let's write our blank equation down and substitute in what we know. Well, the y is 2. It's going to go there. The a we don't know. The b is 1.5. And the x is 2 as well. So let's substitute them in. 2 equals a plus 1.5 times the other 2. Simplify that. Take the shortcut. Yes, you should rearrange it. Make that 3. 2 minus 3 is -1, goes on the other side. So we end up with a equals -1. Now, we've got our b value. We've got our a value. So we have y equals -1 for a plus 1.5x. Great. Bringing back memories. So it should. Now, I will qualify this because when you go into further maths next year, if this is a very important point, we've only used x's and y's, and even when you do it on the CAS, it only uses x's and y's. If your graph has a title here and a title down the side here, please make sure you write that, certainly write the y and x in the equation, but then rewrite your answer using your variables down here on the x, down here on the y. So if it was day and, I'm trying to think of another one, number of ice creams sold, you would write number of ice creams sold equals -1 plus 1.5 times the day. Straightforward? Please remember that. All right, time to go off and get some equations from graphing practice.